Astrophysicist Ray Jayawardhana is our guest. He was once on the cover of Newsweek magazine, and you were young. Not that you're so old now, but what, 27 years old or something? Cover of Newsweek. Why?
Well, it was not so much me that was on the cover, it was our discovery, which was when I was a graduate student, and I was using telescopes down in Chile at Cerro Tololo Observatory to do my thesis work. And I was looking for these dust disks around young stars, but I was looking at ones that are a little bit older than the ones people had known before. The idea was to see how they evolve, whether this material around the stars actually go into making planets. And if they do, how do the dust disks change? So we took a picture, a snapshot of a young star with its own infant planetary system, we thought, which is about 10 million years old. So it's a very young system. The solar system, our solar system, is 4.5 billion years old. So this is rather young. This is a kind of a young snapshot of a young star and its planetary system. And that's what landed the cover of Newsweek.
I see.
Yeah, so it was a very exciting time. It was also my first scientific paper, which got so much attention.
Right.
It was hard to live up to that again.
So on your scale of 1 to 10, the discoveries you've made so far, what excites you the most?
Oh, that's a tough one. There are a number of ones. Actually, the one from 3 years ago when we took a picture of a planet orbiting another star perhaps ranks as the top one.
Okay.
Because that was very exciting to really see, a faint dot next to a young star and say, that's a planet. That's very exciting. That's something people have tried to do for a long time. And that was a very fun and exciting moment.
But nobody's seen any people or bugs
Not yet.
or birds on a planet.
Not yet. And we're developing the kind of methods to be able to do that, right? So we're going to look for things like, we call biosignatures, things like oxygen and methane and water and, carbon dioxide coexisting in the atmosphere of a distant planet that might indicate the presence of life. Now, the problem is, even if you do detect those things on a, let's say a rocky world, a little bit bigger than the Earth, you still won't know if it's slime or civilization.
Or water, something.
Yeah, it could be algae, it could be, technological civilization, it could be a whole range of things. So that's it's the pace of discovery so far, especially in the last 15 years, has been truly revolutionary.
Truly.
But the next big step is sort of, looking for life elsewhere. That's still a challenge because we don't even know quite what to look for because we have only one example. We know of life on Earth, that's it. So what do we look for? Do we look for something identical? Do we look for something very different? And if so, how do we look for something very different? So it's a big challenge, a big question, but one that's likely to have incredible implications, for all aspects of our thought and, life.
It's unbelievable, really. I mean, I know it's probably true, but you have to pinch yourself to think how many solar systems there are.
Yeah.
Are stars made of the same elements as Earth?
Absolutely.
Some of the same, in different?
Different proportions, but in fact, it's deeper than that. The stuff that makes you up was made inside stars that died a long time ago. So the oxygen you breathe, the calcium in your bones, the iron in your blood was cooked up inside stars a few generations ago, and they exploded, they died, and those elements were distributed into space and got incorporated into our own solar system. That's how you ended up here. So we are really made of star stuff, as Carl Sagan used to say.
Yes, we're all star stuff, really. Even if you're not a star in the Hollywood sense, you are a star, sort of.
Or at least you're made of stars. Yeah, absolutely.
So the big breakthroughs in cosmic phenomena have been figuring out what's a planet, what's a star, how solar systems work, why the Earth goes around the sun.
Okay, yeah.
What else?
There's a lot more. I mean, we have a pretty good idea by now of, how the universe formed, how the entire thing, the whole universe originated in this Big Bang model for it. We understand the age of the universe pretty precisely. We've measured it. So there's a lot of incredible advances that have happened in the last 100 years or so. But that doesn't mean we understand everything. So one of the most challenging and embarrassing things about this big picture we have of the Big Bang, the evolution of the universe is expanding, all of this makes sense, it adds up, except the vast majority of the stuff that makes up the whole universe we can't see. It's this stuff we call dark energy and dark matter. And we know it's there, We just don't know exactly what it is. So there's a connection between the big picture of cosmology and studying really tiny particles in the particle physics world, because it's the physics of what makes up those particles, the set of particles that might explain what's going on in the bigger scales.
Sure, but you do know, or I think you know, after reading this, alien Earths by the dozens are out there.
There's got to be, yeah.
How to find them is the problem. One warm, wet, rocky world teeming with life.
Exactly. So we're very close to answering that question. So with the Kepler spacecraft, which was launched by NASA 2 years ago,
yes.
It's out there now orbiting the sun, staring at a little patch of the sky, monitoring 150,000 or so stars, looking for alien Earths. So within the next couple of years, we fully expect to be able to tell you roughly, how common Earth-sized planets are.
But there could be stability enough on a planet somewhere where life, human life, could be, or again, we don't know.
We don't know what kind of life, but certainly we could find planets very soon that have the right conditions to support life as we know it.
Well, we know the moon isn't made of green cheese. We do know that.
No, we do know that. I just saw moon rocks at the Johnson Space Center a few days ago when I was visiting Houston.
Really?
Yeah, rocks brought back by Apollo astronauts. Along with actually these meteorites that we collected. I was actually in Antarctica for 2 months, in December and January. And for 37 days of that 2-month period, we were camping out in the middle of nowhere, gathering meteorites. These are leftover rocks from the formation of our solar system. So in your hand, you can hold a piece of rock from the birth throngs of our solar system, from 4.5 billion years ago. We collected 900 of them in 37 days, and they had just arrived in Houston on Tuesday last week.
900 meteorites.
900 meteorites.
Small.
Most of them are quite small, but the biggest one is maybe about that big.
Because there's always that story you could get hit by a meteorite.
Very rarely happens.
And what
Extremely rarely.
What about a comet? What's a comet compared to a star?
Well, a comet is a small piece of debris that's left over after the formation of our solar system, for example. Okay. And because it's made of ice as well as rock, it gets closer to the sun, some of it evaporates. So you see these big gray tails of gas. And the spectacular phenomena in the night sky. And it's quite possible that we've had a number of impacts due to comets and asteroids in the history of our own planet.
When you hear stories or read stories about UFOs
yes.
and aliens and hear normal humans, well, fairly normal humans, say they've been picked up by a spaceship, do you believe any of it?
I have to say no. I mean, at this point, we don't have any compelling evidence of aliens coming here. And the thing that sort of I guess it's astonishing to me is, I've also, there's a slew of alien movies coming out of Hollywood recently.
Yes.
It's very interesting because we're all clearly fascinated by the possibility of life elsewhere. But the distances between star systems is so vast, it's really hard to imagine travel between star systems. To have the technology to be able to travel, at the fastest rockets we have today, it'll take tens of thousands of years to get to the nearest star. Wow. So even if you imagine much more advanced technology, and if they came all the way, we're not going to be fighting them with our little machine guns.
Probably not.
Because
we'll have to call Richard Branson.
Maybe.
Because he has the money
to
get us there, perhaps. But what you're telling me, in your lifetime, there will probably be signs of intelligent life.
Well, I'm not sure if it's intelligent,
universe.
But I think we will have a good chance of detecting if there's life elsewhere. And I think that will be a profound moment in human history.
And when you're not studying astronomy, and giving lectures and talking to school children and trying to explain to them how important it is we study this.
Yeah.
What are your hobbies? Little jazz?
I love music, live music in particular. I love to travel, so it's convenient that my job often allows me to combine that love of passion for travel with my work. I read a variety of fiction. I play squash, I don't know, play poker with my buddies.
Oh, great.
Yeah, so it's a whole range of things I do.
So a full house, so to speak.
If I'm lucky.
Yeah. Robert J. Sawyer endorsed this book. As you know, he's a wonderful science fiction writer and a friend of yours.
Yes. He lives in Mississauga, wonderful guy.
And they love that some of the things they've been writing about in sci-fi are actually true.
Yeah, science fiction authors have great imaginations, often better than we scientists do, so it's very interesting.
How nice to meet you.
Oh, pleasure.
Thank you for doing this. Ray Jayawardhana, Strange New Worlds.